Hello everyone, today we're going to look at functions, the vertical line test, and functional notation. So a function is a rule. Typically we think of it as an algebraic rule, so we're going to be using order of operations. So it's a rule that associates a unique output value for every input value. So we're going to do some examples. So the first function is y equals 2x. So the rule is to take the input, which is x, and multiply it by 2. So if our input is -4, we multiply -4 by 2, and our output is -8. We're going to put our input and output functions values together as an ordered pair. So it's an ordered pair because the order very much matters. It is the input and then the output. The input is also called the independent, if I can spell, the independent value, and the output is the dependent. Okay, the output depends on the input, and you decide the input, so it's independent of anything else. Okay. And the ordered pair is always the independent and then the dependent, or the input and then the output. So here's another one, y equals 5 plus 8x. If I have an input of 0, my x becomes 0, this cancels out, my output should be 5. I put them together and I get the ordered pair 0, 5. Y equals x squared. I input -3. So now remember, order of operations, I am going to take -3 and multiply it by itself. That's what squared means. So I have a double negative, those negatives cancel, and I get a positive 9. So my ordered pair is -3, 9. How about y squared equals x? So my input is still x and my output is still y, but now I've switched where the square symbol is. So if x is 4, what's y? So we have y squared equals 4. So that gives me y equals 2. 2 squared is 4. But -2 squared is also 4, as we saw in the previous example. When I square a negative, it becomes positive. So in this case, I have an output of 2 or -2. What that means is that it's not unique, and this guy is not a function. It's still a rule, but it's not a function, because the output is not unique. But I could still write it as an ordered pair. It's 4, 2 or 4, -2. But again, it's not a function. There are other ways we can determine if something's a function or not besides just plugging in numbers. And this is if we have the graph. If we have the graph, then we can do what's called the vertical line test to determine whether it's a function or not. So I have some examples here, and what we're going to do is we're going to take a vertical line and run it across this picture. So for each of our graphs. And if it hits the function or the rule more than once, then that rule is not a function. So we'll try it with our first one. We're going to draw some vertical lines, as vertical as I can make them. And you have to look, does it ever hit the function more than once? Hopefully we can tell that the answer to that is no, it does not. And that means it is a function. So I'm going to put yes for yes, it's a function. For the next one, I'm going to change the color because I don't want it to be red on red. So for the next one, I start drawing vertical lines. And do any of my vertical lines hit the function more than once? Yes. All of them except for that last one hit the function twice, hit the rule twice, which means it is not a function. So I'm going to say no. It's not a function. It hits the rule or the graph more than once. Okay. So we go down to our green one. Again, I'm going to draw vertical lines, and do any of them hit the graph more than once? And hopefully we can see no. It hits it only once at most, which means that yes, it's a function. Okay. And then we go to our last one. If I start drawing vertical lines, does it hit my graph more than once? Yes. And hopefully, again, all of the ones that I drew hit the graph twice. So again, the answer is no, it is not a function. Okay, so if you have the graph, it's really easy as long as you can draw vertical lines. So the last part of this section is on functional notation. So our function notation looks like f and then parentheses x. So this stands for f is a function. So we usually use f because function starts with an f, but it doesn't always have to be f. So f is a function of x. So this parentheses is not multiplication. It's not f times x. It's f of x, if I'm going to say it. So the parentheses means of in this case. F of x. F is a function of x. The x is the input. And again, the f is the name of the function. Okay, so this says f of x equals 3x minus 1. Okay, so it is a function. If I put in any inputs, I'm only going to get out one output. So it is actually a function. If I wanted to graph it, it would look something like this. And hopefully we can tell that that would pass the vertical line test. Okay, so it is a function. So now to use functional notation, we're going to find the following. F of 2. So what this is saying is that every x is now a 2. So every x becomes 2. We had 3 times x. It's now going to be 3 times 2 minus 1. And then according to order of operations, 3 times 2 is 6, minus 1 gives us 5. So f of 2 is 5. If I was going to write it as an ordered pair, my input, again, comes first. My output comes second. F of negative 3. So again, every x becomes a negative 3. So 3 times negative 3 minus 1. Again, doing order of operations, it's the same order, right? It's the same function, so I'm still multiplying 3 by something and then minusing 1. So I have 3 times negative 3 is negative 9. Negative 9 minus 1 is negative 10. F of 0. Every x now becomes a 0. So 3 times 0 minus 1, negative 1. Let's try another function. G of t equals 2 minus t squared. So now my function is g, and my input is t. So g of 1, every t becomes a 1. So instead of 2 minus t squared, it's 2 minus 1 squared. Order of operations, I square 1 first. That's still 1. And 2 minus 1 is 1. How about g of negative 1? Here you have to be really careful. Again, remember it's order of operations. I'm squaring the t first. The t is negative 1, so I'm squaring negative 1, which is still 1. So it's still 2 minus 1, which is still 1. And then g of 2. So again, every t becomes a 2. So 2 minus 2 squared. 2 squared is 4. 2 minus 4 is negative 2. Okay, so it's really, really important that you follow order of operations. And I just want you to, read through the book, try out some of the homework, and let me know if you have any questions. Thanks.